Alright, this video will be over the concept of inequalities. These are things you learned about back in earlier grade levels. We're going to review what the symbols mean first. Alright, to review you, this is what the symbols mean. If you have the symbol open to the left with no line underneath it, that's the less than symbol. If that same thing has a line underneath it, that means less than or equal to. And if it's facing the other way, if it's the open part's facing towards the left, that would be greater than if it has no line underneath. And if it does, that means it's greater than or equal to. Alright, and for these couple of examples, I want you to express these in interval notation and graph the solutions. For part A, x is greater than negative 2. Alright, since x is strictly greater than negative 2, that means it'd be a parentheses, because we're looking at the numbers that are strictly greater than negative 2. We're not looking at negative 2 itself, so that's where we'd use the parentheses. And since we're looking at all numbers greater, it'd go on to infinity. And since you can never touch infinity, since you never reach infinity, it'd be another parentheses right here. And if you were to graph that on a number line, you go to negative 2 on the graph. And your book teaches that since it does not contain the endpoint, you'd do a parentheses at negative 2, and you'd shade. Since it's greater than, you'd shade to the right. In earlier grade levels, you were taught to just do an open circle at negative 2. You may remember that. So for this one, x is less than or equal to negative 1. Now since we're looking at numbers that are less than negative 1, it'd be from, all the numbers to the left, so it'd be from negative infinity to negative 1. But since it can be equal to negative 1, we use the brackets around negative 1. But since you never reach infinity in either direction, that'd be a parentheses right there. So it'd be a parentheses around negative infinity and brackets around negative 1. And if you want to draw the number line, alright, that's negative 1. Remember, it'd be a brackets around negative 1. Let's move the marker over here, because the bracket's supposed to be on the marker, so somewhere there's negative 1, and then you would shade to the left. So here's an example. It says solve 3x minus 4 is greater than 8 and graph the solutions. Alright, you'd start off solving it like you would an equation, add 4 to both sides. So 3x is greater than 12, which means that x is greater than 4. So the solution set would be, since it's greater than, be all the numbers from 4, greater than 4, so from 4 to infinity with parentheses. So you go to 4 on the number line, and you would draw a parentheses around the 4. You'd want the numbers to the right. Alright, here's another example. It says solve negative 2x plus 1 is greater than 5 and graph the solutions. So if you start by subtracting 1, you'd have negative 2x is greater than 4. So if you divide by negative 2, you'd flip the inequality, so x is less than negative 2. You flip the inequality symbol since you're dividing by a negative. So the symbol, or not symbol, then for interval notation, since we want all the numbers that are less than negative 2, be all the numbers from negative infinity. No, it'd be a parenthesis since you never reach infinity. From negative infinity to negative 2. Since we're not looking for negative infinity itself, that'd still be a parenthesis around the negative 2 as well. So, if you go to a number line, you would be a parentheses around the negative 2, and you'd shade to the left. Alright, so here's another example. It says solve negative 3x plus 5x minus 2 is greater than or equal to 8x minus 7 minus 9x. Alright, so if we combine like terms, that means we would end up with negative 3x plus 5x, which would be 2x minus 2 is greater than or equal to 8x minus 9x would be minus x and then minus 7. So, we can try adding x to both sides and also adding 2 to both sides. So that would tell us that 3x is greater than or equal to negative 5. So if we divide by 3, that tells us that x is greater than negative 5/3. Or greater than or equal to negative 5/3, rather. So since it didn't say graph, we just need to write our solution set. It'd be with a bracket since it can be equal to negative 5/3. Be for all the numbers from negative 5/3 to infinity. Alright, this example says solve 3 times, open parentheses, 2x plus 1, close parentheses, minus 2 times 2x plus 5 is less than 5 times 3x minus 2. So you need to use the distributive property, 3 times 2x, which would be 6x, 3 times positive 1, which would be 3. For the second parentheses, you can distribute the minus 2, so it'd be minus 2 times 2x, which would be minus 4x. Then negative 2 times positive 5, which would be minus 10. And then your less than symbol, and then on the right hand side, 5 times 3x, which would be 15x, and 5 times minus 2, which would be minus 10. So let's tidy this up. 6x minus 4x on the left hand side would be 2x, and then 3 minus 10, which would be minus 7, is less than 15x minus 10. So let's go ahead and solve this thing. If we subtract 15x and also add 7 to both sides, we have that the minus 7 and the positive 15x will both cancel out, so you have 2x minus 15x, which would be minus 3x, is less than negative 10 plus 7, which would be minus 3. That should be minus 13x, not minus 3x. So now if we divide by negative 13, the negative 13's cancel out, so you have x. Since we divide by a negative, you flip the symbol. It's greater than 3 over 13. So our solution set would be from 3/13 to infinity, and it would be a parentheses around both because it's strictly greater than. We're looking for the number strictly greater than 3/13. Alright, for this example, it says that the revenue and cost of a certain product are given by R equals 4x. The revenue is equal to 4x and the cost is equal to 2x plus 1,000, where x is the number of units sold. At what production level does R at least equal C? So if R at least equals C, that means R could be greater than or equal to the cost, which means 4x must be greater than or equal to 2x plus 1,000. Alright, so if you subtract 2x, that should be 1,000. Unfortunately, I can't write to save my life. But if you subtract 2x from both sides, you have 2x is greater than or equal to 1,000. Which means that if you divide by 2, since we're dividing by a positive number, the x value should stay the same. So x is greater than, the number of units sold must be greater than or equal to 500 for the revenue to at least equal the cost. So if you want to put this in interval notation, it'd be from 500 to infinity. Alright. Here's another example. This is what we call an AND inequality. I'll show you what it means in a minute. It says solve -2 is less than 5 plus 3x is less than 20. Now solve it first, then I'll explain what I mean by the word AND. First, since we have a plus 5, we need to cancel that out. We do that by subtracting 5 from everything. So, -2 minus 5 would be -7 is less than 3x is less than 20 minus 5, which would be 15. So now, divide by 3. That tells you that -7/3 is less than x, and x is less than 5. See, if -7/3 is less than x, that means x must be greater than the left number and less than the number on the right. So, from 7/3 to 5, if it's greater than 7/3, strictly greater than, it'd be around the 7/3, parentheses around the 7/3 and parentheses around the 5. Since it's greater than 7/3, you shade to the right of -7/3, I mean. Since it's less than 5, you shade to the left of 5. That's what I mean by AND. It has to be less than one number and greater than the other. So the interval notation would just be from -7/3 to 5, and it'd be in parentheses since it does not contain the endpoints. So here's another example. Solve 5 over x plus 4 is greater than 1. Alright, so to solve it, you need to get rid of the fraction. In order to get rid of a fraction, you need to multiply both sides by the denominator of the fraction. Since our denominator is x plus 4, you multiply both sides by x plus 4. On the left-hand side, those would cancel out, so you'd be left with 5 is greater than or equal to 1 times x plus 4. Since 1 times anything is just itself, you're left with just 5 is greater than or equal to x plus 4. Now, if we subtract 4 from both sides, that tells you that 1 is greater than or equal to x. Or, if you like the x being on the left-hand side, it'd be x. You just flip the inequality. X is less than 1. Since we're looking for values that are less than 1, it'd be from -infinity to 1. Since you never reach infinity, it'd be a parentheses. But since x can be equal to 1, it'd be a bracket. Alright, it says solve 2x minus 1 over 3x plus 4 is less than 5. What you can do is multiply both sides by 3x plus 4 to get rid of the denominator. On the left-hand side, those would cancel out, so you just have 2x minus 1. Bring down your inequality, and you need to have 5 times 3x plus 4. And if you distribute on the right-hand side, multiply both sides by 5, you'd have 5 times 3x, which would be 15x, and 5 times positive 4, which would be positive 20. And on the other side, bring down your 2x minus 1. So now if we solve this inequality by subtracting 15x from both sides, and also adding 1, we have, well, the negative and positive 1 cancel out, and the positive and negative 15x cancel out. So we're left with 2x minus 15x, which would be negative 13x, is less than 22 plus, or that should be 20. I don't know why it says 22. It should be 20 plus 1, which would be 21. But now you need to divide by negative 13. The negative 13s cancel out, so that tells you that x would be less than negative 21 over 13. So to write this in interval notation, since we're talking about less than, go from negative infinity to negative 21 over 13. Alright, that would be a parenthesis since you can never reach negative infinity. Alright, and negative 21 over 13 since it's strictly less than that. And since we're looking for the values that are strictly less than negative 21 over 13, it'd be a parenthesis.